Continuing with packet 4. Another example of finding the derivative of a function f of x. Again, we use the limit definition of the derivative to do this. Take the limit of the difference quotient as h approaches 0. In this example, notice that we multiply the top and bottom by the conjugate to rationalize the numerator. Does that sound familiar from algebra? And here is our derivative function. Here's an example where we have the curve f of x and we want to give a possible graph of f prime of x using information from f of x. Notice we can look at where the graph of f of x is increasing and decreasing, which corresponds to positive and negative values of f prime of x. And we can split those intervals up where the slope of the curve is 0, or where we have a horizontal tangent line. Here we see we have a horizontal tangent line, which means slope slash rate or of the curve is 0. This means f prime of x is equal to 0, and we can plot that on the graph below. Here we have another spot where the slope of the curve is 0, horizontal tangent line. And again, this means f prime of x equals 0, so we can plot that below. Now that we have two nice points on the graph of f prime of x, we can analyze when f prime of x will be negative or positive. We know to the left of this point of the graph is increasing, which means the rate slash slope of the curve is positive. So that means we will have positive values for f prime of x. We can see here by drawing tangent lines at certain points. to the right of where the rate of the curve is 0, horizontal tangent line, we can see by drawing tangent lines that the curve is decreasing until we get to another horizontal tangent line. This means f prime of x will be negative. And then the curve is increasing to the right of the horizontal tangent line, which means f prime of x is positive. Now that we have an idea where f prime of x is positive, negative, and 0, we can draw an approximate graph of the derivative function. There are some different notations for the derivative as we see below, so make sure to recognize the notations. For applications, we don't just look at the first derivative of functions. The second and the third derivatives are analyzed and useful as well. The notations are expressed here. An example. Here we have a function modeling a rock thrown in the air. Before answering part A, it might be better to do part B first, so we will have the general form of the derivative. The velocity is just the derivative of the position function, so we need h prime of t. And voila, we have the velocity function. So now we can look at the velocity for any time we want. Since part B says for t equals a, I just replaced the t with an a. So now we can answer part A quickly without having to do much work. We just want h prime of 1 and we get that the rock has a velocity of 6.28 meters per second after 1 second. Part C, we want to know when the rock hits the ground, which means position of the rock is 0 feet above ground. H of t equals 0. So we just solve the equation with some algebra. We know already that t equals 0 seconds is where the rock started, so t equals 5.4 seconds is where the rock hits the surface. Part D, we want to know with what velocity the rock hits the surface. So we want h prime of 5.4. We end up with a velocity of negative 10.08 meters per second. That would hurt if your head was there. Ouch!